Right, here we have the circuit set up. We're just using a switch which is here on the circuit. The first stage, the switch will be connected up there to the incoming 10 volts. There'll be a small voltage drop across the diodes and to the output. This voltmeter is showing the voltage on the output capacitor there, which is 9.45 volts, which is a 10 volts minus the drops across the diodes. And this other meter is showing the voltage across the capacitor, so at the moment it's showing minus 0.36 because the capacitor is across that diode voltage drop. So the next stage, the switch goes down and the voltage on the capacitor is 9.59, which again is the 10 volts minus a bit of voltage drop with that diode. The output still stays the same. So now that capacitor charges up and it'll have plus 10 on there. I'll say 10 volts, we'll ignore the diode voltage drops. So that will charge up to the supply voltage, ready for when the switch goes back again. That capacitor will then be in series with the incoming 10 volts, making it 20 volts to go through to the end stage. So if we switch that over again now, so we put the capacitor back up to that point, you'll see that the output volts goes up, but doesn't go up to double because on the first swing the charge in the capacitor is reduced as it charges that one up, so it doesn't get to the full voltage. And there's the voltage on the capacitor discharging as it's going into that one. But in actual practice, this will not be a switch like this, it'll be an electronic switch going at a very high speed. So if I switch that backwards and forwards at a faster speed, you will see that the output does get to almost 20 volts, which is double the 10 volts minus the voltage drops. I've patched up the inverting charge pump on a little bit of breadboard and we'll be going through the operation of that now. The starting point is with the switch closed to 0 volts, and you can see that the capacitor voltage is on C1 and C2 are both 0 at this point. The switch will then switch over, taking the capacitor up to the plus, and now we can see on the voltmeters that the capacitor C1 is charged to 9.6 volts, which is the 10 volts minus a bit of voltage drop across the diode D1. D1 was forward biased in that case to allow the current to flow through to charge the capacitor. So the next step now is the switch goes back to 0. That puts the voltage on C1 across to C2 via D2, and as you'll see, the voltage across the capacitor C1 is then putting a negative voltage which goes through D2 into the output voltage. The voltage at the point of switching, you'll notice, goes down to about 5 volts on each capacitor. That's because the 10 volts is shared between the two capacitors at the first switching point, but then as things are switched faster, as it would be on electronic switch, the voltage does eventually get up to the minus 10 volts, minus a little bit for the voltage drops of the diodes. And for the final part, we've got an IC LM7660, which is an inverting charge pump. As you can see, it's running from 5 volt supply and it's giving out a minus 5 volts. It's driving a small LED. This IC is useful where you only have a single 5 volt power supply, but you have an amplifier that needs a minus 5 as well. So having one of these gives you the minus 5 for the negative side of the amplifier. That's it for this section. Thank you for watching. The next part will be using inductors as the storage medium, and the first one will be looking at the buck converter, which drops a voltage down to a lower voltage.